Hello, today we are going to be covering 4.2 graphing in standard form as well as graphing in vertex form. By the end of this video, you guys will be able to graph quadratic equations written in standard form. So we have a couple of steps written out here. We need to find the vertex. So to find the vertex, we use the equation negative b over 2a. That is going to equal x. Then you need to plug x in to get y back into our equation. So we have an example here. We need to first figure out what a, b, and c equals. A and b are coefficients. These are numbers in front of our variables, and c is a constant. The term coefficient a is always in front of our x squared term. The coefficient b is always in front of the x term, and the coefficient c is always in front of the constant term. So when we're looking here at this example problem that we are going to graph, the coefficient a is 1. The coefficient b is negative 2, and the constant c is 1. So you can highlight these if you want to make sure you know which came from where. And then we will use these to solve for our vertex. So we need to plug the information into our equation to solve for x. Negative b over 2a would be negative 2 over 2 times 1. So 2 over 2, which equals 1. Then we need to plug that back into the original equation to solve for y. So we have y equals this equation, bring it down, 1 squared minus 2 times 1 plus 1. So 1 squared is 1, minus 2 plus 1. So y is going to equal 0. So our coordinate of our vertex is 1, 0. So we can go ahead and graph that down here. We need to find the vertex first, so we did. Over 1 up 0. We can also draw in our axis of symmetry. And then we are ready for step 2. So the other day I had you solve and graph these using a table. That is a completely valid way to do this, but there is a trick that we can use. We can use the pattern 1, 3, 5, 7, and so forth times our coefficient a to solve for the following points that we need to graph. So to get the second and third points of the parabola, go over 1 and up 1 times a. From those 2 points, go over 1 and up 3 times a. From there, go over 1 and up 5 times a, and so on and so forth. So if we try this, our coefficient a is equal to 1. So we need to take 1 times 1. That'll equal 1. And then we plot from our original point. So I go over 1, up 1, both ways symmetric. Then I need to take 3 times a, which will equal 3. And I go from those 2 new points. I go over 1 and up 3. 1, 2, 3. Oops, 1 too many. And then I do that symmetric on the other side. And then I can do 5 times a. So from the 2 newest points, I go up 1 and over 1 and up 5. And then I can graph my parabola. And this will work every time for any sort of parabola graph. So let's try it. There's not much space for work here, but we'll try to fit it all in. We need to start by finding our vertex. Our vertex is negative b over 2a. So I say A is 2, B is -4, C is 1. I plug them in. So -4 over 2 times 2. So we get 4 over 4. So x equals 1. So I can say x equals 1, and I plug that back in. So y equals 2 times 1 squared minus 4 times 1 plus 1. So 1 squared is 1 times 2 is 2 minus 4 times 1 plus 1. And we end up getting that y will equal -1. Now I have the coordinate of my vertex, 1, -1. I can go ahead and graph this. So I go over 1, down 1. That is the coordinate of my vertex. I can draw in my axis of symmetry. And then from here, I just do the cool multiply times a trick. I know that a equals 2. So I just say that 1 times 2 will equal 2. And 3 times 2 will equal 6. And 5 times 2 will equal 10. Now we can't get all of these in there just because we would be off of our graph. So I'm going to start from our vertex point and go over 1, up 2, symmetric. Then from the new points, I'm going to go over 1 and up 6. And then do that symmetric. And then I am already done. So versus making a table and then graphing these, this way is so much easier. All right, and then we have another example. We go ahead and solve for our vertex. Our vertex is -b over 2a. So we have -6 over 2 times -1 because there's a negative out front, a -1 out front there. I solve, I get -6 over -2, so I get a +3 for my x value. Then I plug that back in. So I will have y equals -3 squared plus 6 times 3 minus 7. These can get kind of tricky. If this number x that we plug in is negative, when you square it, it will become positive. If the a value out in front is negative, that means you square and then multiply by the negative. So do the squaring first. So 3 squared is 9. So then you multiply that by -1 on the outside, and you get -9 plus 18 minus 7. So you end up getting 2 for your value of y. So we have our vertex, 3, 2. Go ahead and graph it over 3 up 2. And then we can do our a trick, where we take 1, 3, and 5 all times our a value. In this case is -1, to plot our points. I'm going to quickly draw in my axis of symmetry. And then we will graph over 1, and then this time you have to go down 1 instead of up 1, symmetric. And then from these points, over 1 and down 3. And this time we can do the next one, over 1 and down 5. And we are good to go to draw in our parabola. parabola. So with the shortcut, this is actually pretty easy. We're going to try a few more. These are just review from the last lesson. They should go pretty fast, and they'll be even quicker since we're not making a table anymore. So our vertex form is y equals a parenthesis x minus h squared plus k. And the vertex of these is the opposite of h, comma k. So we have once again start by finding our vertex. The opposite of h is always in the parentheses, k is always added or subtracted outside. Opposite of h is negative 2, comma k, keep the sign there, is negative 4. You can plot your vertex, negative 2, negative 4. Then we can do our a shortcut. So we take 1 times a, we take 3 times a, and we take 5 times a, and you could do so on and so forth. But we'll run out of graph space. And then you graph from here. I'm going to draw in my axis of symmetry. So I go over 1 and up 2. I go over 1 and up 6. And then from there I'd run out of space as well. So I'll just stop there and draw in my graph. Call it good to go. Next one is very similar. Our vertex, opposite of h, negative 2, comma k, negative 3, plot it. Then I know my a value is actually 1, because it doesn't show up there, so I take 1 times 1, 3 times 1, and 5 times 1 to know where to graph next. So from here, I go over 1, and then up 1. From the new points, I go over 1 and up 3. And from those even newer points, I go over 1 and up 5. And then I can draw in my parabola. All right, another example. We need our vertex, opposite of h, comma k. There's no k, it's just a 0. Graph it, over 1, up 0. Draw in the axis of symmetry. Now notice this is a negative 1 a value, so we are going to have 1 times negative 1, 3 times negative 1, 5 times negative 1. So I go over 1, down 1, over 1 from the new points, down 3. From the new points, go over 1 and down negative 5. And then draw in the graph. And we have one more of this type. We have to find our vertex, opposite of h, negative 2, comma k, keep it the same, graph it, negative 2 up 4. We see our a value is negative 3, so 1 times negative 3, 3 times negative 3, 5 times negative 3, and so on. Notice the negative will make it be a sad face graph, so we know it's going to be pointing downward. I'm going to go ahead and do my axis of symmetry, and then I'm going to go over 1, down 3. I'm going to go over 1, down 9. And I have run out of room from there, so I will stop and draw in my parabola. And that's it. It's pretty simple with the shortcut.